Here it is, an in-depth explanation of every question in this May.June 2023 paper 21. Let's go. So let's jump right in with question 1, and they want us to find the straight line, find the angle ADE. You know, if they tell you there's a straight line CDE going from C to D to E, then they pretty much tell you, hey, you need to use this piece of information, okay? Because they don't tell us stuff for no reason. Okay, what do we know about angles on a straight line? That equals 180. Okay, even though we can see it's a straight line, right? Okay, so we're gonna have to use that. Now find angle ADE. Angle ADE is this angle going from A. That doesn't work, does it? Going from angle A to D to E, which means it's this angle here. Right, the first thing we need to know is that all angles in a quadrilateral adds up to 360. You know that triangles, they add up to 180. Now if you've got a four-sided shape, square, rectangle, parallelogram, it's just two triangles. So that's 360. Okay, so these three angles we have, if we subtract them from 360, then we'll have the angle called ADC. Yeah? ADC. So that's the one we're working at. So we're working out angle ADC. Alright, now waste your time here. You just grab the calculator. 360 minus 104, 71, and 56. Looks like my calculator is on the wrong settings. There we go. 129. It is. So this angle here is 129. Now we're going to use this fact that they tell us that's a straight line. Knowing that angles on a straight line is 180, we subtracted 129 from 180, and that will of course give us 51. So 51 degrees it is. Okay, make sure to show your working out. Yeah. So you get a mark for showing how you subtract that from 360, a mark for 51. Okay, it's a comfortable question, they say. Parallel lines. Oh, that's how people often think. They look for parallel lines, they don't know parallel lines. There's no parallel lines here, right? Remember. Only parallel when they tell you so. Only used, yeah? They told us that there's a straight line. So you know you need to use that. Nothing about parallel lines. Right, now we got to do some time. Precious time. A train journey starts at 9:43 in the evening. It takes 8 hours and 32 minutes. Find the time the journey finishes. Okay, a good method to use is the time hop method, where you jump. Okay, so from 9:43 till 2200 or 10 o'clock at night, that will be 17 minutes, right? Then if we jump from there till midnight, which is 24 hours or 000, whichever way you prefer, that's another 2 hours. Okay, so we've done our 2 hours, 17 minutes. So now we can do a big jump. Of course, we have 2 hours, we want 8, so we should need another 6 hours. So we jump another 6 hours, that will now give us 8 hours in total. So that will be 6 in the morning. Alright, so we got the 2 hours plus the 6 hours, that's the 8 hours. We got 17 minutes, and we need 32 minutes. So how many minutes are we short? What's 32 minus 17? We're 15 minutes short. So that means we need to jump another 15 minutes. Time hopping it's called. So the time the journey finishes is 6:15 in the morning. Alright, sleeper train. Okay, there we go. Is it 6:15 or 6:15 a.m.? Only one mark here. Okay, yeah, just looking at this, remember, there's 60 minutes an hour, not 100. Common mistake there. Question 3. Now we got the parallel lines. You see this? The moment you see parallel lines, you're going to look for that Z, which is of course alternate, or the F, which of course is corresponding, and a very popular one these days, the C is the co-interior, which is not equal, they add up to 180. Yeah, so look for those three things and you're sorted. Okay, and again, you see, you read what they say. Alright, they mention the two parallel lines, you know you're going to use the parallel lines. Okay, find the value of A and the value of B, giving geometrical reasons for each answer. And those geometrical reasons are very specific. There's only one thing they're looking for. So let's look at A. A is right opposite that 58. So A is 58. Straightforward. Okay. Now the full reason here is vertically opposite angles. But I wonder, oh yeah, they do want vertically opposite. Okay, so remember that word. I don't know if you will get marks for just opposite. It says vertically opposite. It's not very clear in the mark scheme, so stick with vertically opposite. I thought opposite would be enough, but apparently not. Okay. Then B. Alright, there's many ways to get B. Okay. We got alternate angles, which means this one is 58. We got corresponding, which means this one is 58. Either way, B is not 58, okay. The quickest one would be doing co-interior angles, which means these two angles together, between the parallel lines, they equal to 180. So all we need to do is 180 minus 58, which of course was that 122. Okay, which you would do the same if you do alternate and angles on a straight line, or you go corresponding into angles on a straight line. It's the same. Okay, but I'm going in for co-interior angles equals 180 degrees. Let's see, will that give me my marks? See here, they're happy with just interior. You don't even know the co. You don't need the co. You don't need the equal 180. Whereas vertically opposite, you need the vertically. You know, the more you write, the better, because you never know. Okay, so it means just for the word interior there, we'll get the marks, but apparently we need vertically opposite. There we go. Sure, another year, another time, that would be different. Okay, just the more you write, the better. Question 4. Now again, people don't read these questions properly. Okay. By rounding each number correct to one significant figure. I bet if we read the examiner's report, they're going to say people did not do that. Yeah, look at that first sentence. There was a significant minority who did not address the demand to write each number given calculation to one significant figure. And then they wasted time to find their answer that could not gain any marks. Okay, you see, if you don't read the question, they waste a lot of time. This is probably the most important bit here. Okay, because that makes the whole question a lot easier. And if you don't do that, you waste time. So we need to round everything to one significant figure, which means the first digit. 6.7, having a 7 next to it, we need to round that 6 up to a 7. That's one significant figure. 2.1, we round to 2. 18, the first significant digit is that 1. Next to the 1 is an 8, so we need to round the 1 up to a 2. Okay, but it's not, you can't round 18 to 2. Yeah? 18, we need to round it to 20, so we need to put that 0 in as a placeholder to tell us that's a 20, not a 2. Then minus, first significant figure there's a 5, next to it is a 9, so we round it to a 6. Remember, 1 to 4, you stay the same, 5 and up, you round the number up. Okay. Now that everything is rounded to one significant figure, which does not count the placeholders, so tell us that's a 20 and not a 2, we can do the calculation, because in the end this is just an estimate, I don't want the exact answer. 7 times 2 being 14, 20 minus 6 being 14, and 14 divided by 14 being 1. Yeah? So you see here, you get a mark for that rounding, which you don't get. And then only if you got that, you get 1 not from wrong working, which means if you've done it any other way, you don't get your mark. You can get, if you got 0, you can get 1 special case mark if you rounded 3 of them correct. Okay, read this question carefully. Yeah, one significant figure. Eric has 4 colors of paint. There's the probabilities. Find the value of x. Remember, all probabilities, all possible outcomes, always add up to 1 or to 100%. If you add up fractions or decimals, adds up to 1. If you add up percentages, adds up to 100%. Simply meaning that if we add 0.3 and 0.35 and 0.13, what is that? And 0.65, 0.78, yeah. Yeah, 0.78. Then the remainder, we need to subtract from 1 to see what do we need to get to 1. Because he only has 4 paints, no other paints. So all the paints needs up to 1. And that, of course, is 0.22. Nice and easy. 0.22 or equivalent means you can write 22%, you can write 22 over 100, you can write 11 over 50. Okay, 1 mark for the method. That's what I showed you. Okay. Well, if you don't have that, if they see 0.78, I'll give you the mark. Question 6, they give us a formula. The first thing is just write down that formula. So the volume of a sphere is 4 over 3 times pi r cubed. And then check, what did they give us? With the diameter. Okay, see, this is where you need to pay attention to the diameter, of course. When you have a sphere, that's not a circle, that's a sphere. You see, there's a shiny bit. That's the diameter, 4.8. The radius would be halfway. So first of all, to find the radius, we need to take the diameter divided by 2, which will be, no, that won't be 4, it will be 2.4. That's the radius. So to get the volume, they're really just checking if you can spot little details, like, yeah. So let's get that on the calculator. See there, I forgot one of the brackets. Bam. 57.905. Etc. Okay. And then they say at the beginning of the paper, if they don't say how to round it, which you don't, round it to 3 significant figures. So rounded 57.9. Let's have a look. Okay. They do award marks if you round it to less. Okay. You get a method mark even if you put the wrong value in there. Look, they got 4.8 in there. It should be 2.4. So if you use the diameter, if you put it in the formula, you get 1 mark. As if you don't have the right mark. Okay. Yeah, see, the most common error is that people did not spot the diameter thingy and they used the whole thing. Okay. Now look at them. Some of them swap it around, and some of them use a square. Okay. Be careful with these little details, not to lose your marks there. Question 7. Alright, now one of the main things students always tell me is like 1 to 25,000. It doesn't give any units. Well, it's because it works for any units. 1 millimeter is 125,000 millimeters. 1 centimeter is 125,000 centimeters. 1 kilometer on the map is 125,000 kilometers on the map. Okay, that is possible. So that means that 1 centimeter on the map, which is what they gave us, is 125 centimeters in real life. So that means 9.4 centimeters on the map. We have now taken this ratio, we multiplied it by 9.4. Since 1 became 9.4. So we need to do the same on the other side of the ratio to know how many centimeters that is in real life. So it's 125,000 times 9.4. 1,175,000 centimeters in real life. And of course, nobody talks like that. I'm going to drive 1,175,000 centimeters this weekend. Now we need to change that to kilometer. Okay, so remember, cien centimeters, that's 100. Yeah, well, 100 centimeters. Cien meaning 100. Cent meaning 100, that will be 1 meter. And then, of course, kilo meaning 1,000, so 1,000 meters, that will be 1 kilometers. Okay, so what does that give us? 100, 1,000 is 100,000. So 100,000 centimeters, that's 1 kilometer. And we're not going to multiply it, that will be massive. That will be to the sum and back. So we're going to divide it, of course. You take the 1,175,000 divided by 100,000. And that's what, 5 zeros? So we just go 5. We move the decimal point 5 spots, so you use your calculator. 1, 2, 3, 4, 5. There we go. 11.75. Okay. Don't round this because it's an exact answer. We only round answers that is not exact. Sounds like a reasonable answer, doesn't it? Yes, it is. Okay. So you get a mark if they saw 1175 somewhere. Okay, or you change the scale before you started multiplying. But yeah, that's what you multiplied and then divided or equivalent. The biggest problem here is the conversion between centimeters and kilometers. So remember what centi means: 100, kilo, 1,000. Okay, so remember your scales. Millimeters, 1,000. Centimeters, 100. Kilo, 100. Deci, 10. Study these things, yeah? Question 8. Straightforward. The nth term. So the first term in the sequence, we need to change that n for a 1. So to find the first term, let's call it term 1. You need to go 10 minus 1 squared, which is easy. 1 squared is 1, 10 minus 1 is 9. That's the first term. Term 2. Change that n for a 2. Now what? 2 squared is 4, 10 minus 4 is 6. You see, this is a sequence going down because we got a negative in front of the n. Okay, term 3 will be 10 minus 3 squared. 3 squared is 9. 10 minus 9 is 1. Okay, straightforward. There. 1 mark if you get 2 correct. 0 if you got 2 wrong. Now with a little bit harder part, find an expression. So first thing we check is what's the term to term rule? How do we get from one to the next, right? And we're adding 3 each time. Okay. Now this is not n plus 3. That's the most common thing people write. It's not n plus 3. Okay. There is another sequence where we add 3 every time. This sequence. Yeah, you recognize this sequence? We're adding 3 each time. Yeah, that's the 3 times table. The first term is 3, the second term is 6, the third term is 9, the fourth term is Fourth term is 12. It's the 3 times table. What is 3 times? That is 3n. So the term to term rule, this thing that you add each time, that is what goes in front of the n. Okay. Now, of course, we don't have the 3 times table. We got 7, and then we got 10, and then we got 13, and then we got 16. So let's look what's happened here. Instead of the 3 times table, starting with 3, we start with 7. That is 4 more. And there again, look, 4 more, 4 more, 4 more. So it's the 3 times table, but 4 more each time. And that's the answer, 3n plus 4 or equivalent. Okay. If you spoil the answer, you lose a mark. Don't spoil the answer. Don't do these silly things. Alright. Look at that. 3n, n plus 3 seen a number of times. Stop doing that, please. Question 9. Similar triangles. Which means it's the same triangle, just a different size. Which means the ratios of the sides are the same. That means if we take the bigger triangle, this side, which is h, and it's always advisable to write the thing you want to find out first, and we divide it by the corresponding side, which is the height of the triangle, 5.6. Because it's similar, the ratios would be the same. That means if we take the 8.1 and we divide it by the 7.2, we need to get the same answer, and that's why we put an equal in between. That's what similarity means. Same and a ratio. Okay. So all we need to do now is rearrange this, and we need to get rid of this 5.6, move it to the other side. This is divide by 5.6, so we move it this way. It becomes a times. 5.6 times 8.1 over 7.2. That's all. Let's do that. You can put that 5.6 in front as well if you want. I mean, same thing. And there we go, 6.3 centimeters. Think, does this make sense? Well, if this is 5.6, 6.3 is bigger. Yeah, makes sense because the size is bigger, but not by much, so that one's only a little bit bigger. Okay, let's have a look. 6.3, correct. Look, they got it the other way around. You do write it the other way around with the h below, then you have to do a lot more shuffling around to get the answer. I mean, you have to multiply that there, you need to multiply that there, you need to have to divide the 7 point there. You have to move everything. My method's better. Just move the 5.6. Mark scheme isn't very good this time, sorry. Anyway, look at this. Some people saw a right triangle and they used Pythagoras immediately. Alright, think carefully. Think carefully. Similar triangles, ratios. You need to recognize keywords and know what to do with them. Similar triangles, got to do with ratios. You write them like this. Question 10. Without using a calculator. In bold. You got a calculator. What's going to happen if I do this? 1 over 7 equal. Nobody's going to check. I mean, you just do this. You go, bam. What do they want? They want us a mixed number. We change this to a mixed number by pressing Shift and this button here. And there's the answer. 3 and 6 over 7. Now, I mean, they show, so you say you must show you're working out, but I'm going to full marks now. Well, look here. You only get these A marks. Yeah, if you have everything that comes before it. So meaning if I really were to do this in an exam, you get 0 marks because they say show you're working out, and you only get an answer mark if the method marks are there. So you need to show every step. You need to change this mixed fraction to an improper fraction first, and you do that by multiplying 2 times 7 and then adding it to 1, which is 15. So that will be 15 over 7. The denominator doesn't change. And the second fraction is fine. Okay. Then with division, we always leave the first fraction the same and we invert the second one. Okay, you see that what I did? I swapped the 5 and the 9, and then we multiply. Okay, now there are different ways to do this. You can do 15 times 9, 7 times 5, but a little bit easier is if you just simplify before you multiply, meaning I can divide 15 by 5, and that will be 3, and I can divide 5 by 5, and that will be 1. Okay, if you can divide the same number, common factor, top and bottom, makes things easier, because now 3 times 9 is 27, and 7 times 1 is 7. Then you just need to think, well, 7 times table, 7, 14, 21, that's 3 wholes, that's where I got the 3 from. 21 to 27 is 6, that's the remainder, and now bam, I got the right answer. Okay, now we can get the marks. 1 for changing this to an improper fraction, 1 for the correct method, invert and multiply, and then bam, get your marks for the correct answer. And you've done it. Okay, just look at here. Candidates are instructed to show all their workings, so multiplication step needed to be explicit. You need to clearly show how you flip and multiply, okay? They are quite a bit fussy about that, it seems. Looking at question 11, this is clearly a transformations question. Now remember, there are 4 different kinds of transformations. Let's think of them. There is a reflex. That's when we got the mirror image and something flips over, like looking in a mirror. There's a translation. That's when something moves across the page. There is a rotation. And of course there's the enlargement. When something changes size. Okay, so when they say triangle, describe the single transformation that maps triangle A onto B, clearly has a change in size. Okay, do note that this counts 3 marks. Okay, so the first thing we need to write is which transformation it is. So you have to write enlargement, because that would get you your first mark. Okay. Next, what an enlargement has is scale factor, telling us how much it enlarged by. How much is it bigger? Of course. Now this one is quite straightforward. We're going from A to B, right? This is 1 square high, now it's 2 squares high. So this is 2 squares wide, now it's 4. So it's a scale factor of 2, of course. That will give you your second mark. Going for 3 marks here, so we need one more thing. And that's the center of enlargement. Let me write that down. Or you can just write center. That's fine. Okay. And that's the point it enlarges from. To do this, we connect the corners and see where they meet up. Okay, you need to do this quite accurately, or you can be wrong. Now the center of enlargement will be a coordinate, and that's where all the lines come together, like so, at that point there. So remember, coordinates is always along the corridor, which is 0, and up the stairs to 7. And now we got full marks. So enlargement, there's always 3 things. Well, 2 things and the word. Scale factor, the center. Now it's done. Next one, triangle A to C. A to C. So here, tracing paper would be helpful. Okay. We trace the shape. Okay, so let's look. A reflection means it would have flipped over. Mirror image. Now that clearly didn't happen. Okay. A translation means the shape just moves across the page like this, and the orientation stays the same. Okay. It's not enlargement. We don't have a change in size. It could only be a rotation. Rotate it. You see, like this. Okay. So again, we're going for 3 marks here. So we're going to start by writing down what the transformation is. Rotation, 1 mark. Okay. Then there's always the center of rotation. Again, this is a coordinate, and this is a point that this moves along. Okay. Now finding that point is sometimes not so easy. See, okay, I'm close there. Maybe I should move a bit the center to the right. Okay, trial and error. Let's move 1 more to the right. Okay, we're too high. Let's move down. Oh my goodness. Let's try over here. Oh, there we got it. Just had to keep trying. See, that's the center. It moves around that point there. So we have it, which is this point here. Again, that's the coordinate along the corridor to 3, up the stairs to 1. So this is the point 3, 1, and that gives us a 2nd mark. And the last one, we describe how the rotation is. Okay, the direction and the angle. So we're going this way, of course, looking at the clock, same as the arms move, that will be clockwise. That's the direction. We are moving it in. And how much are we moving it? Let's have a look. Okay, that's 90 degrees. So this will be 180, half a turn. This will be 270. This is 360. Okay, so 90-degree turn. You can also, if you want, draw a line. See, from there to there. Well, that's a 90-degree turn, isn't it? So all we need to write is the angle. And we got full marks. Of course, you can, if you want to go the other way around, right, you can write anti-clockwise 270 degrees. That will also be correct. Okay, if you want to complicate things. Meaning, if we were to go anti-clockwise, 90, 180, 270 will end up in the same place. Okay, but you've done it. Well done. Question 12. Right. Read the information carefully. They say AO, OB, and OC are radii. Cool word, that one, radii. Of course it was. Radiuses, radii. The most important thing to remember about radii of a circle is that they are always the same length. So we can put in there ourselves these little lines, saying these 3 lines are all the same length. And immediately some stuff starts to pop out there. Yeah, in that arrowhead is that it consists out of 2 isosceles triangles. It tells us AB equals BC. Okay, got those little lines there, right? Everything they tell us for a reason. We need to use. Their triangle AOB is congruent to triangle COB. Remember this word congruent? It's like similar, but it means exactly the same. Same size, same length of side, same angles. We're similar. The one is bigger, the one is smaller. Congruent, exactly the same. Drawing around the correct criterion for this statement. So why are they this table? It's just 1 mark, so don't waste a lot of time on this, but I'm going to go into this in detail, because sometimes they do ask it. Right, so first of all, if we look here, there's the 2 triangles, yeah? You see them? AOB is the triangle on the left, and COB triangle on the right. Now they have a common side here. That means that line OB equals OB, which sounds silly, but it's a side that is above triangles. And that's a side that is the same. Yeah? Then we got OC, which is OC, OA. They are the same length as well. So we can say OC equals OA. We have now used this fact about the radii. So we know that there's a reason, right? Again, these are 2 sides. Okay, what else have they told us? They told us, different color here. This one, BC and AB. That's the fact they gave us, and we're using it, so we know we're doing the right thing. AB and BC is the same length because they told us it is, and that's another side. So I'd say these 2 are congruent, because if 2 triangles, if all the sides are the same length, they are exactly the same. Okay, because if one is a little bit longer, then the angle changes, the other side gets longer, and it's not exactly the same. So side, side, side is my reason, I'd say. Let's see if I'm right. Side, side, side it is, without going on too much fluff about it. Well, that's interesting. Look at that. Everybody in the exam got full marks on this question because there was a mistake when they printed this, which has now been corrected, so this is correct. But in the original paper, that was wrong, and everybody got a free mark. That's fun. Question B. We got here is circle theorems. So we make it bigger. Again, now you really, really, really want to read in detail what they tell you here, because you know that's the stuff you're going to use. P, Q, R, and S are points on a circle. So imagine when I read that, I think about a cyclic quadrilateral. And TQU is a tangent to the circle Q. Okay, so immediately when I read tangent, you think about the 90-degree angle. See, cyclic quadrilateral here, opposite angles are always 180 degrees. Meaning, let me change this. Yeah, let's make that 80. See, this one's 80. Come on, go on. You get the idea. Opposite angles. There's always 180 degrees. And then there's, of course, the tangent. Tangent and a radius is always 90 degrees. Now, yeah, you know what I mean. You get that on top of that. Anyway, so that's the first 2 things they've told us. 4 points. That's what I think of. PR intersect SQ at the center of the circle. Whenever I see a center, immediately I know there's going to be something called radii. Lots of radiuses. Yeah, look, OR is a radius, OS is a radius, OP is a radius, OQ is a radius. They're all the same length. Immediately we have 3 isosceles triangles. Okay, radius, isosceles triangles. That's what you need to look for. Okay. And then we got parallel lines. Okay, lots of stuff here. The moment you see parallel lines, you start looking for those alternate angles. Yeah. Don't look for them if there is not a parallel line. Some people is parallel line crazy, and yeah. The F angles of skis is corresponding. All right. The moment you see parallel, you see. All right. Well, look for those things. And they give us an angle there, 42 degrees. So, what do they want? OSR. Let's use a color. OSR. OSR, which means we go from O to S, from S to R. So we need to find this angle here. Now, I don't know what that angle is. So the best thing to do is forget about the angle and just start finding any angle you could possibly find. Okay, so change colors, we just go for it. Right, so we know the tangent, this is 90 degrees. Okay, 42 is that angle over there. Okay, what can we find with 42? Now this immediately brings to mind something called the alternate segment theorem. You see this triangle here? That one there means that this angle here, 42, is equal to the opposite angle inside that one there. Alternate segment theorem. Let's see if I can find this. It's this one really. Okay, look at this angle here, 66.2, and the one opposite there, 66.2. 44.6, opposite angle in the triangle, is 44.6. Alternate segment theorem. You can see if I move these, the opposite 72.7, 72.7, 34.6, they always stay the same. Okay, so have a look for this. So that's what we have. Where's the question? Okay, now before I marked all those radii, so it means we've got isosceles triangles, which means this one here is also 42 degrees. Okay, one I haven't mentioned, of course, just getting messy, is the beautiful butterfly theorem, or you can call it the bat theorem, or the bow tie theorem, or whatever you want. Yeah, that makes two beautiful shapes like that. Let's see if we can find that one. Where is it? There it is. Angles in the same segment. You can see the two green angles here, they're always the same size. The two orange ones, they are the same size. Yeah, well, supposed to be. Yeah, 30.8, 30.8, 33.6, always the same. Got nothing to do with the center. So ultimate segment theorem, there's a lot of stuff going on here. So meaning, now this is 42 degrees, this one over here is 42 degrees, and this one here, alternate segment theorem. So give us OSR 42 degrees. Okay, then PQS. Oh, this is getting a bit messy. Let's see if we can clear stuff up a little bit. Next angle is PQS. PQS. Mark it. PQS. PQS. And I already got that one. 42 degrees. See? Because it was base angles of an isosceles triangle. Got it. 42 as well. POS. Let's see, where's POS? POS is this angle on the outside there. Alright. So, what can we do? Well, there is stuff we can do. I already know what's the answer. The answer is 84. Instinct tells you, well, we'll just find these angles here, and then we can do 360 minus those divided by 2. Perfectly fine. We can do that. And then I'll show you a quicker way. So we do 180 minus 42 twice, which is 84. So that means 96. That means this one here will be 96, and that one there will be 96. So we do 360 minus that 96 twice. And this is now where I get lazy. 360 minus 96 minus 96, and then divided by 2, we get 84. Okay, what was that? What was that? 100. What was it before? So 168, and then we divided it by 2, we get 84, and that's it. That means this is 84, and that's 84. But there was a quicker way to do this one. All right, which is the beautiful angle at the center is twice the angle on the circumference, if you could spot that. See, this is 42, 84 is exactly double that. Yeah, if we go here, let's see if I can find that. There it is. Okay, just the thing with that one, it looked like this. The one line was on top of the other one. Okay. Well, it's supposed to be the angle at the center is twice the angle on the circumference, but this is not quite working, is it? Huh. Anyway, it's what it's supposed to be. Just imagine it's that. Okay. Either way, it's 84. Is there any more? No, that's it. 42, 42, 84. Follow through marks is available. So if you got that first one wrong, but you got the second one the same as the first one, then you get this mark. Do you make sense? If you said this angle was 40 and you said this one was 80, and you said this one was 40 as well, and then you said this one was 80, you can get follow through marks. You will get this one wrong, of course, but these will be right because this is the same and that one's double that one. Interesting, isn't it? Alright, interesting here is they don't give any marks for angles that was written on the diagram. In this case, they wanted the correct answer on the line to know that you recognize the notation of how they name the angles. So that's quite important, yeah? How we name angles. QSR, going from Q to S to R. Make sure you understand that. Question 13. Keyword here, compound interest. Immediately think of the formula. The amount you have at the end is the principal, the amount you put in the bank. 1 plus the rate. The rate in this case is R. It's always R. So it means always a percentage. And to the power of N or T, whatever you want to, yeah, it's the time. How many years or months. Okay. Now, they've given us the amount. No, they haven't. They have not given us the amount because you don't put $6,000 in the bank and then you have $621.70 after 8 years of saving it. No, that's going backwards. Bad bank. Okay, that's only the interest. It's only the extra money. So this is wrong. This is not the interest, the amount. This is only the interest. The total amount you'll have in the bank, of course, will be the money you put in plus the interest. So this is the principal plus the interest you earned, which means in the bank you'll have $6,621.70. That's how much the amount you have in the bank, and that is what the formula for compound interest works with. Okay. Whereas with simple interest, which is not here, okay, I'm just going to tell you quickly, simple interest, that formula is I. So that one works just with the I. And then it's PRT over 100. Okay. So don't get confused. Simple interest, unused interest, compound interest uses the final amount. So we put that in. The final amount you have is $6,621.70 in the bank. You put 6,000 in already, or Anya, rather. The rate, we don't know it. And it's been there for 8 years. Now we just need to solve this thing. Rearrange it. First thing I'll do, I will divide the 6,000 on the other side. I'll divide 6,000 from both sides. So we'll have this left like this. And we'll have the 1 plus R over 100 to the power of 8. The next thing to get rid of is that power of 8, because that keeps everything inside the brackets captive. We can't move anything outside the brackets before that 8 is gone. So what is the opposite of something to the power of 8? Well, that's to the root of 8. Now the brackets are gone. Okay, this is where I like to pick up my calculator and start putting stuff in. So we're doing root 8. Press shift, put the little 8 up there. Inside we got 6621.7 over 6,000. Okay. Now be careful here. Do not round anything until the end. So I'm going to keep that on my calculator screen. We can write it down. 1.0124 equals 1 plus R over 100. So the next step would be to subtract the 1 which is 0.0124, and then multiply the 100, which is pretty easy to do. That will give us, move the decimal by 2 spaces, 1.24. Now if there's any need to round it, we can do it with a calculator as well. So remember, we subtracted 1 and then we multiply it by 100. There's the full answer. Rounded to 3 significant figures, 1.24%. That is the interest rate. 1.24, if you got more digits behind, that is fine, they don't mind. Okay, you get 2 marks. Well, 1 mark for adding up, getting the total amount. That's the first step. Alright. And then another mark for dividing and root 8. And then a mark for the final answer. So looking here, yeah, lots of people use simple interest, like I told you, rather than compound interests. Keywords you need to know, simple, compound. And then of course, lots of students just use the interest and not the total amount, like I told you. Okay, very important there. Make sure you know when they're talking about the interest, the total amount, when to use which one. Very important. Question 14 is a proportion question. Okay, so they tell us y is directly proportional, which means you put the fish to the square, not the square root, the square of x plus 3. What does a square look like? Yeah, a square looks like a square. The square, so look to it, the power 2, that's what they mean. Okay, see, I've done that first sentence now in mathematical language. I've just translated it. Now, if we want to put an equal, because we like equals more than fishes, we need to bring in the constant of proportion there. That is the number you multiply it for. Like when we did similar triangles, how much bigger the one is than the other one. Okay. These steps are important and they always follow the same procedure. Because now we can start figuring stuff out. We can substitute. We can substitute the x equals 2. So we can substitute the x, that x for a 2, and the y for a 5. And we can work out that constant, right? So 2 plus 3 is 5. So it's k5 squared. 5 squared, of course, is 25. So it's k25, or better is to put it in front. Okay. Now, so to solve k is we need to divide that. Don't let your ease of stuff get over you. 5 over 25, which of course is 0.2, because it's 1/5. So you can write 1/5 or 0.2. Nobody's telling you what to do. I like 0.2. K is 0.2. What we can do now, we can take this equation we had before and we can write it, but now that we know that the constant is 0.2, we put it in there. Now we can work out anything else we want. So we can work out what is y, which is cool because we've got y equals when x is 1. So we do 0.2, x is now 1. So that would be 1 plus 3 is 4, 4 squared is 16, 16 times 0.2, whatever that is, yeah? Or just put in your calculator to save time and not get a headache. 3.2. This is one of those questions where you can just learn the steps and make sure you do it slowly so you don't put the square, not the square root. You got direct and not indirect proportion. It's the stuff you need to practice a little bit. 3.2 or equivalent, which means probably 3 and 1/5 or 3 and 2/10, whatever you want. You get 1 mark for writing that equation. Yeah. So this is important. You need to write this. There's no other way. And then 1 mark for substituting 1 in there. So this step is important. You need to show these things if you want to get full marks. Learn the method. So, linear proportion, whatever that means. Inverse proportion, you know, when the one is below the line. Putting a square root, that's a mistake I often see, rather than a square. And not putting in that constant of proportionality is the cool word for it. Okay, make sure you do those things. Question 15, we got a bag full of buttons. So, there's a bag full of buttons. There's many different ways to do this. I like to draw a tree diagram. It's just so much better. But what we're looking for, because the probability that one button is green and the other button is not green. So this is all about being green or not green, okay? So when you pull out that first button out of the bag, you're going to ask yourself, is this button green or is it not green? How are we going to word that? Let's write here. So green, is it green or not green? You're not bothered that I write in blue, are you? Okay, so what's the probability that that button will be green? Well, there's 5 green buttons, and how many buttons in total? So 13 buttons in total, right. So the chance that when you pull that first button out is green is 5 out of 13. Meaning the chance that it's not green is the other ones, the 8 out of 13. Alright, then you go for a second button, or Maya for that. But here is a very, very important keyword, most important, very important. Without replacement, which means she doesn't put the button back. She sews it on a shirt somewhere. It's not in the bag anymore. Okay, meaning now when we go for, again, green or not green, it can happen again. When we go for this, there's only going to be 12 buttons left. So all my probabilities will now be out of 12 because one is gone. Now if I pull the green button, there are one less green button as well. So there's only 4 green buttons left and not 5 anymore. But all the other buttons are still there, all the blue and the white ones. So this stays the same. Can you see? 4 plus 8 is 12. It adds up to 1 still. If I pull the button that's not green, there's one less one. So I took a blue or a white one. So there's one less not green button. But all the green ones will still be there. And there were 5 of them. So this shows all the possible pathways the future can take. It's like a sci-fi movie. Right, so now what are we looking for? Let's see, what path are we looking at? Okay, let's go. Calculate probably that one button is green and the other button is not green. That means that we pick a green button and then not a green button. But be careful now, it didn't say the probability that she pick a green button and then not a green button. She said that one of them is green and one is not green. So meaning there's another path we can take. She could pick the first one is not green and then the second one is green. So there's 2 possible things that can happen. She picks a green one and not a green one, or not a green one and a green one. Make sense? Okay, so we got 2 paths. Now here is the thing with probability tree diagrams. When we move along the branches, we multiply. Remember that. So I've got green and not green, which is this branch here. We're going to have to do 5 over 13 times 8 over 12. And down here, we're going to do the same. It's 8 over 13 times 5 over 12. Okay. Now, just use your calculator, save time, don't waste your time. That gives us simplified 10 over 39. Now, I don't know if you've noticed this, but we're going to get the same answer for the other one, because multiplying fractions, multiply top by the top, bottom by the bottom, you get the same answer. But just to show you that I'm not talking nonsense. Okay. I mean, there is, of course, shorter ways to do this, but same answer. Okay. So we got 2 possible ways to get the outcome we want. Now, what do we do with those 2 possible outcomes? The first probability being 10 over 39, and the second probability being 10 over 39. Now, this is the OR rule. The one thing's going to happen or the other one, not both at the same time. And that's when we add. Tree diagrams, moving across, you multiply, but if you've got numbers at the end that you both need, you add them up. And that gives us 20 out of 39. And I bet that's the answer. Now, what if you wrote it as a fraction or a decimal? Alright, so basically we had this times 2. what can you write it as 50? You want to write it as 512820 or 51.3%. I think the fraction is better. Let's look at the mark scheme. Yep, definitely fraction is better, but the OE means or equivalent. So yeah, if I guess you wrote at least 3 significant figures, 0.513, that would be equivalent. But write 3 significant figures, minimum. Okay, or 51.3%. But the fractions is more simple. Okay. So, yeah, they give a mark for seeing those and then multiplying by 2 or adding it together. So, show some working out, please, people. Show your working out. You get marks for having these 5 out of 13 and stuff, and then for multiplying it by 2 and the answer. So, yeah, you see here, the without replacement is important. Recognizing then that you had to make the one less. Okay. People that tried to do blue and white rather than non-green. So look carefully what they want. Okay. Paying attention to detail is important. Question 16. The magnitude of a vector. Let's try to explain this using a grid. So the magnitude of the vector here is -4, 5. Now remember, vectors, the top one tells you how much to go left or right, along the corridor, up the stairs. If it's negative, you go to the left, positive, you go to the right. Bottom number tells you how much to go up and down. So if it's positive, you go up, of course, and negative, you go down. So this one, we need to go 4 to the left and 5 up. Okay, so on a grid, it would look like this. All right, so we're at the point somewhere in the universe, and the 5, that was -4 at the top, so it means we need to move 4 squares to the left. That's a -4. And the 5 means we do 5. Yeah, remember, vectors have got direction. And we go 5 squares up. 1, 2, 3, 4, 5 squares up. Righty-ho, so that means, yeah, that we have moved now from there to there. Bam. Okay. The magnitude simply means how long is... I'm not good at this, am I? How long is this line? And if you recognize there, what we got there is a beautiful right angle triangle. And who's famous for right angle triangles? None other than, yes, Pythagoras. Okay. Meaning we want to find this, so we call it x. Yeah, it's going to be x squared equals 5 squared plus -4 squared. Okay. And then we just need to square root that. Okay, that's all. That is what it means by the magnitude of. So on your paper, what you want to write, and often magnitude is indicated by 2 straight lines, which just means it's always positive. Whatever you're going to work out, magnitude is not negative. Because when you square a number, it is always positive, because a minus and a minus is a plus. Okay, so meaning if we put -4 squared here, or we just put 4, it doesn't matter, because 4 times 4 is 16, and -4 times -4 is 16, so it will be 25 plus 16, which of course is 41. And then we worked it out. Okay, so the square root of 5 squared plus, it's a waste of time, you just square root of 41 equals 6.403. If you're going to round it, 3 significant figures, that stays 0, so 6.40 shows. Alright, that's it. That's what magnitude means. You don't need that 0, 6.4, unrounded is also good. There, if you've done the squares or equivalent, it's showing that you've used Pythagoras. And that's all it is. Right, now we're going to move on to more vectors here. These are the ones that's usually more fun. Okay. Tells us there's a triangle. We can see it's a triangle, so they must be telling us it's a triangle for a reason. A is the midpoint of the straight line OB. Okay. Now, OA is X. Now the thing about vectors is, if they go in the same direction, and the line is the same length, then they are the same. Meaning, if A is the middle, which doesn't look like the middle, it's kind of an optical delusion, but anyway, it means this line here and that line there is the same length. So if OA is X, AB is also X, because it's going in the same direction and it's the same length. So, we now know we have used this piece of information. OC is Y, we can see that. Find CB in terms of X and Y. So what we want to know is CB, meaning we start at C, vector's got direction, that's why we've got an arrow. We're going from C to B. Now the rule with vectors is, if we don't know what that is, we take a path that we do know. Path that we do know is this one. Going in this direction and then shooting across. That's the path we do know. Okay, and what would that be? Well, going from C to O, and what's very good is to write down the path you're following. We're going from C to O, and then we go from O to B, and that will give us CB. Now C to O, you see that's Y, but we're going in the opposite direction, which means we do a negative Y. But from O to B, we're going in the same direction as the arrow, and we're going double the distance, so that's 2x, and that will be CB. Now they like to put the positive number first and then the negative, but if you write minus y plus 2c, it should be correct. Okay, I'm telling you, it should be right. Interesting here that they saw only a few students found this correctly. Vectors is always a difficult topic. Okay, so make sure if you use all the information given, it shouldn't be too hard. Question 17, simplify. One of the main things we need to remember, there's a brackets there for a reason. That means everything inside the bracket is to the power of 3/4. The 81 and the x to the power of 12, the power now. Power to a power, if you remember your index laws, you multiply them. Okay, now, if you remember correctly, that if we got a denominator, that means a root, and the one above means cubed. And 12 times 3/4, of course, being, what's it, 9? But you know, you're probably saying, huh, what's going on? You don't need to stress about this. If you just know how to use your calculator, it's not that hard. You do 81 to the power of 3/4. Bam, you got the answer. No stress, no time wasted. Okay, I'm just saying, sometimes they want to know more stuff, so you need to know that that is the same as, let's say, the root 4 of 81 cubed. But I see, you don't need to do that. And the 12 times 3/4, I mean, you can put that in your calculator. And bam, you got it. It's 9. So it's 27x to the power of 9. So don't sweat it. Just remember, everything inside the brackets is power to that. Power to the power, you multiply, put in your calculator, get the right answer. Okay, 1 mark for 27, 1 mark for 9. No sweat, nothing else they wanted. Yeah, it's easy as that. Use your calculator. That's 1 mark, that's 1 mark. Oi, sun went down, but we'll continue. Question 18 we're on. So let's see what's going on here. And it's a question about bearings. Okay, 3 towns, U, V, and W, funny names for towns. Okay, let's use every piece of information carefully, very carefully. U is due east of west. That's the first piece of information. Let's see how we can use that. All right. Now remember bearings. North is always 0 degrees. What's then east? Always 90 degrees, and that's the second rule of bearings. There's the third rule, doesn't matter. It's always 3 digits. South is 180 because we always go clockwise with bearings. Always clockwise. So west will be 270. That's the 3 rules. North is always 0. We always go clockwise. Always 3 digits. So if U is due west of V, meaning if we got north goes straight up, of course, like on any good map, then this angle here going around, that's 270. Now that's the first piece of information processed and used. Second piece of information, angle UVW is 125 degrees. Let's do that. So UVW, going from U to V to W, that is 125 degrees. Okay. Right, now what? Calculate the bearing of U from W. My word. Let's process that piece of information. U from W. From W means we are at W, yeah? It's like when you're traveling through the world. So I'm going from London to New York. You're in London. That's where you want. So from W, that's where we're at W. To U, from W to U. Okay, so we're going in that direction. Again, the rules of bearings. We need to start north. We need to go clockwise. So this is the angle we need. Goodness. Right, we got problems. How many marks is this? 4 marks. Okay, so what other information do we know? What? We got a triangle. Triangles means trigonometry. Okay, trigonometry. What do we know about trigonometry? Well, first of all, if we have a right angle triangle, we can use Pythagoras, but only if we want to know sides. If there's angles involved, we use SOHCAHTOA. Do we have a right angle triangle? No, we don't. Okay, meaning we got a triangle that is not a right angle. Let's draw the same triangle over here. Okay, so we got a triangle that is not a right angle triangle. Okay, then we use what? You use the sine rule or the cosine rule. Yeah, remember those two. So when do we use what? First thing, the sine rule. And the sine rule we use when we have an angle and the opposite side. Easy as that. If you see we've got an angle on the opposite side, you know you're going to use the sine rule, because then you can find another angle or another side given that you got another side. So if we got the side here, we can find the opposite angle there. And that's what we have. We got 125 and 62.4. We use the sine rule. We got 27.3, so we can find the opposite angle. Okay, so remember the sine rule. The sine rule is sin A, which is an angle, over A, sin B over B. Lowercase a and b meaning sides, uppercase letters means angles. Okay, now my best piece of advice is always put here what you want to know. Now we want to know this angle here. That will help us a little bit. Finding part of the bearing, there's still a whole other piece we don't have. But anyway, we're going in the right direction. So we're going to write sin and the angle we want to know. What's this the angle we want to know called? Well, it's the angle from U to W to V, with W in the middle. So we're going to use U, W, V. That's the angle we want to know. Over the opposite side, 27.3. That will be equal to the sin of the angle we have, 125, over lowercase the side that is opposite of that, 62.4. Right, so find the angle. We need to rearrange a little bit. First thing we'll do, we'll multiply the 27.3 on the other side. So we have sin UWV equals 27. Handwriting today is horrible. 27.3 times sin 125 over 62.4. Then we need to move the sin. Okay, so angle UWV. And when we move that sin to the other side, we get the inverse, the opposite of sin, which is sin minus 1 over 27.3 times sin 125 over 62.4. Okay, they give us lots of space. So angle UWV is, where's the calculator? $21. Look at that. Nice. 21.0006793. Now they say don't round answers till the end, but with all those zeros afterwards, I think a solid 21 is good enough. So, sweet. Let's just get rid of the clutter. Okay. Just get that. We now have this angle here, which is 21 degrees. That was helpful. We've made progress. We got closer. Definitely got some marks. Don't have the bearing yet, but we're getting there. Right. Now, the next step. What we need to do now, we need to find the rest of that angle. We've got only a little bit of it. So what can we do? What information do we have? Now with bearings, smart thing to do is look at parallel lines. Okay, let's swap to another color now. Dark green. Okay, parallel lines is always very helpful. And we got parallel lines here. Because these north lines always form parallel lines. So we got a V and we got W. Okay. Now, of course, due west means this is a 90-degree angle. So if we take this 125, we subtract 90, we get, what's that, 35 in it? So this angle here will be 35. So like over here, you see, that's 35. How is that helpful? I'm not sure yet. At all. I don't know if that's going to help me at all. In fact, I don't think that's going to help me at all. Can't find another angle though. We can find this one here. Let's do that. So, forget about the 35. Let's find that angle over there. Angles in a triangle being 180. So if we subtract from that, the other two angles, we'll get 180 minus 125 and 21. 34. That's 34. Now, is that helpful? I think that will be helpful. Because we can draw the north line here. Okay. So we make this U. That means that angle there would be what? That angle would be 90 minus 34. What was that? 56. So this is 56. Well, we got some information here now, right? We got some good information here. Okay. One thing we could do, we can do co-interior angle, corresponding angles means this angle here is 56. You see what I mean? That angle there is 56. You see what I'm seeing? I'm seeing a lot of stuff, man. You can do now 180 minus 56. What was that, 124? Or you can just do 56 plus 180 because that's a straight line. Either way, you do 56 plus 180, which will be 236, or you do 360 minus 124, which would be 236. Whichever way tickles your fancy, because that's the answer. What a wonderful question. Did you get that? 236.000 if you want to put it. You do get 2 marks for using the sin rule. Well, you get 1 mark for writing down the sin rule. Look, they got it the other way around, which I don't think is very smart, but that's what it is. Or then by rearranging it, that's the 2nd mark. Yeah, then I did the 180 plus the 56. Yeah, different ways, whatever I showed you, 2 ways or equivalent. If you got 0, you can get 1 mark for marking the correct bearing at W. Oh, interesting. If you just draw this arrow here, let me do it in red. Okay, apparently, if you just draw this like this, if you get 0, yeah, only if you get 0, get 1 mark for that. Looks a bit messy. Okay, but that's what you remembered. Trigonometry triangles, use trigonometry. If it's not a right angle triangle, use the sine or cosine rule. Bearing is always north, going clockwise, a lot of practice, and you'll get these things sorted. See, not many students got this right. Only a few used their sine rule correctly. Remember to go in the right direction. Be careful. Question 19. Sketch the graph of y equals cos x. Now if you ever forget what the graph looks like, you can always just put it into your calculator. Cos 0 is 1. See? So I put, remember, use a pencil. Just use a pencil. Cos 0 is here, is 1. So you remember the graph would start there. Okay, then you can put cos 180. So when we got 180, it's gonna go minus 1. Okay, then we got the 360, so put cos 360. Oh, we're back at 1. Okay, so at 360, we're back at 1. That doesn't help you. Go in the middle. What's between 180 and 0? Cos 90. Cos 90 is 0. So there in the middle goes for 0. What's halfway between 180 and 360? 270. Cos 270 is 0. Okay. I hope this is enough to make you remember what the graph looks like. But if not, put in some more values. Okay. It goes freehand. Draw it. A nice curve. Make sure. Yeah. Look at the mark scheme. What do they say? Where it goes through the points. That's important. So 0, 1, 361, 1. Okay. Okay, so it needs to make clear that it's at 1 there, minus 1 there, and 1 again up there. Okay. Then it says solve the equation. Right, now you use your pen again when you're writing stuff. So how are we going to solve this? Well, first let's rearrange. We're going to move the plus 3 to the other side. So we got 5 cos x equals, the plus becomes a minus. Then the 5, this is 5 times cos x. So now we need to divide the 5. And then moving the cos, which means the inverse of cos is negative 3 over 5. That minus can be above, below the line, in front, doesn't matter. And now we got something to type into our calculator. Alright, so we got shift cos negative 3 over 5. And we got an answer. X is 126.869. Okay, very important now. Look at a lot of things. It tells us the answer needs to be between 0 and 360. And bam, 126.869 is. So that's one answer. It also tells us at the beginning of the paper, give non-exact numerical answers. This is not exact. To 3 significance figures. Okay. Or one decimal place for angles in degrees. Okay, it says it there, always. It's always been like that. So angles we give to 1 decimal place. Where are we? There we are. So we need to cut this question off there, and because this is a 6, we're going to round that number up 1, so that's a 9. 126.9. Oh my god, there's another space. We need to find another answer. Oh, what the hell's going on here? Right. So, whoop up the pencil again. We're going to have to do something. Okay. Now, minus 3/5, which if you know your stuff is minus 0.6, isn't it? Because minus 6 over 10. So meaning, if we go here, minus 0.6 is roughly over there. Okay, so if we go across from there to meet the graph, and we go down, we get an answer. And that's the answer they gave us. Remember, this is 90. So this will be 100. And it's 26.9. That's the answer the calculator gave us. But there is another answer if we continue. And we go up. There's another answer over there the calculator didn't give us. Okay. Luckily for us, everything is symmetrical. Yeah. That distance from 180 will be the same as that distance there. It's one way of seeing it. Or this distance here from 126.5 will be the same distance here. And what is that distance? That distance is 126.9, not 5, because handwriting is ugly. So this is 126.9. Same thing. So you can do 180 minus 126.5 plus 180. Or we can just subtract it from 360. Or we can learn that formula about finding the other parts. But we got the graph there. Let's use it. So to find the other answer, we do 360 minus 126 point. Let's do the unrounded bit. So our answer is more accurate. See, my answer is still there. So I do 360 minus my previous answer. And bam, we got an answer. 233.13 rounded to 1 decimal place, 233. 33.1. We're not finished here, because we can check if our answer is correct. Okay? Remember the original formula there? Yeah, that one there is equal to 0. Well, let's have a look. Is this correct? If we put 5 cos, the angle I just got is 233.1 plus 3. The answer should be 0. Almost. Why isn't it correct? Because I rounded it. Look, if I put a 3, it's a bit closer, yeah? If we put the original answer, which I didn't write down, it will eventually be 0. It's very close to 0, because I used the rounded answer, which is correct. We can put the other answer in there. We got first 126.9, but let's be very accurate. Let's put the 869, and bam, see, very close to 0 again. So, correct answer. I know it is. Look, the mark scheme is going to confirm what I said. Okay, be careful here. You see, rounded to 1 decimal place or more, not less. Don't round it to 3 significant figures. 127, you're not going to get your mark. 230, you're not going to get your marks according to this. Okay, rather leave it unrounded or 1 decimal place. You get 2 marks for getting 1 correct answer. Or if you don't get that marks, for rearranging. Okay, so basically, to have the short story short. You get 2 marks if you got this answer. If not, you get 1 mark for that, and then the third mark is that. Yeah, there's no 4 marks. You understand what I'm saying? Okay. Okay, very interesting what they say here in the examiner's report. Okay. It's a skill we need to practice, drawing these trigonometric graphs, people. And it's so easy. Just use your calculator to find the right points and make sure it goes through the right points, right? It's not like you have to memorize it. You've got a calculator there. You can check it. Okay, but you need to be accurate. You need to show the turning points correctly. At 0, 360. Okay. Off linear. People drew straight lines. No idea of symmetry. Oh my God, people that didn't study this. It's a wave shape. People don't even know it's a wave shape. Okay. Alright, it needs to be accurate. When solving, most people got the first correct answer. It's not uncommon to find the correct one, but the second one was not even attempted. Okay, look at this. Candidates should consider how the sketch and part A can help them find the location of further roots on the trigonometric. So using your graph there to find the other answer is very helpful if your graph is right. Okay, so study it, use your calculator, and it's easy marks in the end. Question 20. Complete the table. I will. Okay, so remember, this is y equals, there's a y there, there's a y there. And they give us the x's, there's x's there. So what we need to do is we take that x and put it there. So minus 0.5, put it into the equation. And that's what we're going to do now. Okay, let's just clear the mess I've made. Alright, so we type in the equation. 3. In brackets, when you are squaring a negative number, it's very important to use brackets. Minus 2. Minus 1. First one there, 3/4. They're using decimals. You could use fractions or decimals. It doesn't matter, but I'm going to continue with the theme of using decimals. Okay, but I'm sure you can use fractions. Okay, and then the next one is 0.5. So all we need to do is go back and remove the minuses. So in there we put the 0.5 and we get minus 1.25. Okay. Now, remember, this has got an x squared in it, so we know it's going to be a parabola. It's a quadratic equation. So draw it on the grid as accurately as possible. Please, please, please take your time. Use a pencil. You can rub stuff out when you make mistakes. Minus 1, 4 means we go along the corridor to minus 1 and up the stairs to 4. Minus a half, 0.75. Okay, count the squares. Each square is 10 squares, so each square counts for, on the vertical axis, counts for 0.1. 7.5. Take your time, be accurate. 0 minus 1. Half minus 1.25. One zero. And 1.5, 2.75. And then with a free hand, carefully. Good, isn't it? Correct curve. Okay, make sure you plot them correct. Be careful. Okay, so when you should know it forms a parabola. So if you see that it doesn't form a smooth parabola, then go look at your values. Look if you made this mistake over here. Okay, this is weird. People see, they know it should be like this, and it's not. I don't know. Okay. Okay. Candidates will benefit from practicing drawing smooth curves. Okay, so basically, right? One smooth curve, don't miss the plots. Try to be accurate, okay? Don't waste your time with ugly looking graphs. Go through the points, one smooth line. Question C. Let's look carefully at what's going on here. Okay. Few things has changed. It says 3x squared minus 4x minus 2. That is what they give us now, equals to 0. But before they gave us 3x squared minus 2x minus 1. You see that? There's something going on, something fishy. Let's write this down. Let's write this down. Okay. So, the graph we have is 3x squared minus 3x squared minus 2x minus 1. Now they give us 3x squared minus 4x minus 2. Before it was equal to y, now it's equal to 0. So what we need to do is we need to get those two graphs the same. I mean, so if we want to use the graph we have, we need to have the same equation. We've got different equations, so that's not too hard to do. What we need to do is we need to the minus 4x, we need to add 2x, because minus 4x plus 2x is minus 2x. And to the minus 2, we need to add 1. If we do that, then our equation here, this one, will become 3x squared minus 2x minus 1. Which is great, because that is exactly what we had. It's our graph. It's our graph. But when we do something on the one side of an equation, we have to do the same on the other side. So we need to add 2x over here and add 1 as well, which we added to 0 will be 2x plus 1. And now here comes a nice bit. Right? So we got the graph we've drawn on the left here. Nice. And then over here we got 2x plus 1, which is now equal to y, because they both, yeah, you see that? This and that's the same. 3x minus 2x minus 1 was equal to y, and now 3x squared minus 2x minus 1 is equal to 2x plus 1. That means that y equals 2x plus 1. Now that means now we can draw the suitable straight line that they're talking about. Now you remember how to draw straight lines? I hope you do. It's not too hard. Remember, straight lines always come in the form y equals mx plus c. C being the y-intercept. I mean, where it crosses the y-axis. So here it crosses the y-axis at 1. Nice. There we go. Another line goes through there. Now we just need a few other points on the graph to... Okay, so there are many ways now to proceed from here. One way to do this is find the x-intercept, where it goes through the x-axis, and by that we can make y 0, because when y is 0, that's where it crosses the x-axis. So meaning 0 equals 2x plus 1. Move the 1 to the other side, it becomes minus. Move the 2, we divide the 2, so x goes through minus a half, which is over there. We can also use the gradient, that's the m. Okay, so the gradient is what's in front of the x. The gradient will be 2, which we can write as 2 over 1. The 2 means the up and down. The gradient, remember, the gradient is the change in y over the change in x. So it means for every one value we go to the right, we change in x, we go 2 values up. Okay, so meaning if we move a half to the right, we go a full value up. If we move 1 to the right, from minus 0.5 to 0.5 is 1, we go 2 up. Okay, just scales are not the same, so don't count the squares, look at the values. If all of that confuses you, just go to the old-fashioned x and y, you know, and you just pick a few values for x. Okay, if you make x 0, 2 times 0 plus 1 is 1. You know what I'm saying. If you make x 0, then y is 1. If you make x 1, so you got y equals 2 times 1 plus 1. Y is 3, so there I got another point. Yeah. Making x2 is not going to work because we're going to go off the graph. Yeah, you can make x minus 1. So y times 2 times minus 1 plus 1. That is minus 2 plus 1 is minus 1. Yeah, look, they're all in a straight line. Show you 3 ways to draw this damn straight line. So let's do it. Let's do it. With the ruler. And where does it cross? There. And that's where we get the answer from. Okay, so look carefully. What is the scale on the x-axis? Well, there's a lot of squares between that 0 and minus a half. So every 2 squares would be 1.1 of the value. So that's 0.1, 0.2, 0.3, 0.4. Minus 0.4. Look at it carefully. Let's see if we're right. Yeah, they give you some leniency. I'm smack bang in the middle, which means I'm a genius. But you can go hard, 1 square either way. Alright. If they see you got the 2x plus 1, you get 1 mark. Second mark for drawing the line correctly. And then reading the value. Right, it says only the strongest candidates. That's you. You're a strong one, yeah? You're going to do it. That rearranging, getting the right equation to draw, that was the hard bit. Let's do what I did. It's not that hard, okay? Some people did use the quadratic formula, which they gave you 1 mark for if you wrote the correct answer. Okay, if you were... Okay, but try to draw that line correctly. Be one of the strong ones. Question 21. Right, moment to talk about the gradient of a curve, you need to differentiate. Remember how to differentiate? You need to multiply that index with a number in front. So there's nothing, there's a 1. So 3 times 1 is 3x. And subtract 1 from the index. 3 minus 1 is 2. That index there is 1. 1 times minus 12 is minus 12. Subtract 1 from 1 is 0. Anything to the power of 0 is 1. So we've just differentiated. Okay. Now to find the gradient, we need to put the x value of the coordinate into the x value of the differentiated value. So we're going to do 3, that value is 1 squared minus 12. 1 squared is 1, 1 times 3 is 3, 3 minus 12 minus 9 will be the gradient. Done. Okay, so 2 marks for writing the differentiated. Well, basically 1 for the 3x squared and 1 for the minus 12. ISW meaning ignore subsequent working. So if you wrote a bunch of gobbledygook after that, they will ignore it. Okay, and then the minus 9. Okay, then it says find the coordinates of the turning points. Okay, now recognizing that anything with an x cube, of course, if you got an x cube, you got a cubic graph. So it will have 2 turning points, a maximum and a minimum. Alright, and what happens at those turning points? Well, the tangent would be horizontal, which means the gradient would be 0. So that means if we take our differentiated equation 3x squared minus 12, which is equal to the gradient, which now at the turning points are 0. Now we just need to solve this. Different ways to do this. We can factorize, or we can just move stuff across, whichever tickles your fancy. I think I'm just going to move that minus 12 over there. So we get 3x squared. The minus 12 becomes positive. Divide the 3. So x squared equals 4. And then we do the square root of 4. Okay, now remember, we need 2 answers. And the square root of 4 has 2 answers. A positive and a negative one. Because 2 squared is 4. That's why the square root of 4 is 2. But minus 2 squared is also 4. Because minus 2 times minus 2, 2 negatives makes a positive. So that's why we can say the square root of 4 is always also minus 2. So there we go. 2 answers. X is 2 and x is minus 2. Okay, well the calculator only gives you 1. So here we got 2 answers, 2 and minus 2. So we clearly need the y values. Now where is there a y around here? Where can we find the y for the y coordinate? Okay, please note that there's no y. There's no y over here. There's no y, well that y there, but it means differentiate there. The nearest y we can find is right there. So this means this is the equation we're going to use to find the y. So let's write that down. Y equals, what was it, x cubed minus 12x. So first, when y was 2, well, x was 2, y would be 2 cubed minus 12 times 2. But this does, the end of the paper, brain is juice, just whip out the calculator. Don't waste your time, your clock is ticking. 2 cubed minus 12 times 2 minus 16. So that's that one. And then the wonder of this is we can just change now the 2 for a negative 2 to find the other answer, but remember to use the brackets. Oh, we get 16. So remember what we did then was we did y equals minus 2 cubed minus 12 minus 2, and that gives us smooth 16. Done it. There's the correct answer. They got it the other way around. You get 1 mark for setting it equal to 0. And then you get another mark for getting x is plus or minus 2. And full marks for getting the coordinates correctly. Right, so minority of candidates actually knew what to do here. Differentiation. Something you might want to go study because they're going to put it in every paper. Okay, almost every paper. A lot of papers. Okay, so go study this. And you'll do great because you can do it. See you again next time.